So I want to go over one of these problems with you to get you started. The equations I've given to you, but you need to remember that if we're looking at this side of the equal sign for either equation, that's before the collision. And then this side would be after the collision. Another thing, you could have more than two things colliding. So if you have a third person or a third car in the collision, you can just add on an additional MV to both sides. So if we look at number one, it says we have a 350 kilogram Biz runs east at 105 kilogram Chris moving east. So this would be mass one and mass two. And then it tells us that Biz is running 22 meters per second. Chris is running 5 meters per second. Find their velocities after they have an inelastic collision, which means they stick together. So if we have inelastic, we're going to use this second equation. So we're going to have Biz is 305 times he's going 22 meters per second plus Chris is 105 and he's moving at 5 meters per second. Now, I did say they're both moving east, so we're going to have both of these be positive. Watch out for your directions because if one was going east and one was going west, you would have to make one negative. So then that's going to equal their joint velocity times their masses added together. And now it's just a matter of solving. So I'm going to make this easier, solve each side separately. The 305 times 22 gives me 6,710 plus 525. So that's going to be a total of 7,235 for this side. And then my 305 plus my 105 is 410. So V 410 equals 7,235. 7,235 divided by 410 gives me a velocity of both of them tangled together of 17.6 meters per second. And that would be my answer. Let me know if you have any questions. Good luck.